Engineering Design Lab is a startup based in Toronto, Canada. We've developed a vehicle that we're calling WAL-LE, which is Wheeled Arctic Lander Low Emissions. WAL-LE is an amphibious electric vehicle, so it can traverse water as well as aggressive terrain. There's a missing link between Canadian Forces, Arctic offshore patrol vessels, and the Arctic terrain itself.
It's like we're building the Batmobile without Bruce Wayne's money.
Is it easier to...
There's no ports, so there's no way to get personnel and equipment from those Arctic offshore patrol vessels onto land and inland.
There we go. This is one of the arms for the wheels. So the wheel will mount, the motor will go into that shaft there. They can lift up and it'll independently rotate around. Yeah, oh, that's exciting.
What we're building is not just another amphibious vehicle. It's a whole new type of vehicle. The way that it's been configured with independent actuators on the suspension arms allows each wheel to move up and down independently, each motor to turn independently, which gives it new possibilities in terms of how it can move through space. Not only can it swim, not only can it drive, but it could also walk and perhaps even run.
Electric vehicles require a lot less maintenance because they don't have a lot of complicated mechanical components that regular 4x4 vehicles have, such as differentials, transmissions, and transfer cases. Overhauls are less complicated, they require less tools, and much more likely to be able to be done in the field or closer to the theater of action.
Okay, beauty, they're powered up.
I mean, the Xbox controller was... I mostly selected this since it's a quality peripheral, but really we're controlling the system from a separate computer. And we just wanted some sort of standard joystick interface, something that would be quick and easy for someone to pick up.
Looks good.
Yeah, it's awesome. All black. Stop.
Look at that stuff there.
WAL-LE can break down by removing 8 bolts on the chassis and allows the chassis and the boat to come apart. The chassis can then become much more narrow with the wheels still attached, is able to be rolled into a shipping container. The boat stacks on top of it, and all the equipment fits inside a 20-foot equivalent unit, which can be closed up and shipped anywhere around the world. Electric vehicles are better in general because they have zero emissions, so less harmful particulates going into the atmosphere, especially in sensitive areas like the Arctic. We have an articulating suspension system that allows it to change its height on the fly, and also independently at each wheel, enabling it to traverse terrain that otherwise might hamper traditional vehicles. It can do things like lean into turns or carve, like a motorcyclist or a skier might do.
I wonder how fast the Mars rover goes.
Oh, this one's a bit faster than Mars rover.
Oh, really?
Mars rover's pretty slow.
So there's a lot of novel ways to actually move this vehicle through the aggressive terrain we expect to encounter in the Arctic.
Well, I think he understood my hand went like, see? I want to just
I have 55 right now.
Today we're going to Cherry Beach to test the amphibious vehicle for the first time. So far we've only driven in an alleyway, and we want to get it on some real terrain and perform some real maneuvers. I do see the U-Haul over.
2 of you, maybe.
We have 4 guys on it. We can lift
Maybe on the same circuit.
Watch out, it's
Well aligned. I think that's our next step is
Wait, it's crawling.
okay, we're crawling. Stop.
This tail will be longer, then we can pull in from both sides. Oh, try not to run me over.
but yeah, maybe move to the side.
Thomas, I trust you.
Yeah.
Okay. That's not bad.
There's no longitudinal torque. It's all moment around the center, right?
Okay.
Okay, give him momentum. Right.
You have to kind of like get it going a little and then turn.
Okay.
Okay, so it's just low torque.
This is the first time testing the vehicle on soft terrain, so we're running some issues with traction and just some of the vehicle controls with turning and things like that.
Oh, it feels like about 1 degree. It's not so bad. Yeah, you can see it's still liquid water out there. Can you extend that actuator more? If you can extend that actuator, you might be able to get this to go back to the ground.
It's durable. It's fast. It's got the oomph. We weren't even using the boost mode. I was watching the command station. Nobody really used the boost mode at any point when they were controlling it, so we've definitely got some headroom to go faster. We just need to manage this power. So Z and I have been cooking up some ideas on how we could improve the controllability.
Test day almost complete.
I think part of the problem is
So we're back at Cherry Beach today to test some of the new modifications we've made to WAL-LE.
Dead zone is set to 20%.
We felt it was actually much more useful to do shorter tests and then be able to reconfigure the vehicle as necessary and then take it out again.
the idea of these ice axes is basically gives the vehicle performance as if it had a tire, twice or 3 times the size, able to climb over much larger obstacles.
If the vehicle is swimming along in the water and it comes up to a large sheet of ice, getting out of the water could be potentially tricky. If there was a set of claws that could come down and dig into the ice, it could help lift the front wheels up onto the ice, and then the front wheels could gain some traction and help lift the rest of the vehicle onto the ice. On test day 1, we were a bit traction limited, and we were digging a lot of holes in the sand because the tires weren't compliant enough to maintain grip, and the control algorithm didn't give us fine enough control over the vehicle, so it was very easy to just spin the tire. The tire that we have now, we're very happy with. We're running it at extra low pressure. We're running it at 0.5 psi. We're not having these problems with digging holes, and it's so soft you can literally roll right over your foot. You wouldn't even feel it. Check.
We will be testing our entry into the water, a right turn maneuver, and then reshoring, just to make sure that all our systems are operational in our current configuration with the suspension, the ice climbing arms, all the motors installed. So that's kind of the plan.
Testing is where it all comes out, where we're iterating, testing new things at a small scale to be able to quickly understand what is valuable and what is not, and then taking those learnings and applying them to a full-scale vehicle that we would then be taking to the Arctic and be operating alongside Canadian Armed Forces and the Royal Canadian Navy. I think we always knew it was going to be fast, especially on land. That part we were able to analyze. Today, after seeing it in the water, we understand that WAL-LE is just as good in the water as it is on land. You really get the best of both worlds.